So today let's go with our chapter probability. So before getting into the exercise, let's just revise what are the basic concepts of this probability. As we know, this probability gives us the ratio of favorable outcomes to the total outcomes. That we can write it as P of E. This P of E is nothing but the probability of getting any kind of event. The probability of any event is equals to number of favorable outcomes by total outcomes. Total outcomes we know, like all possibilities of getting any event comes under outcomes. But what is mean by favorable outcomes? This favorable outcomes, the outcomes of an event that are favorable to its occurrence. That means which satisfies the given condition. Those all events comes under this favorable outcomes, and the value of any the probability of any event, that value ranges from 0 to 1. This we can denote it as 0, which is less than or equals to probability of any event, whereas the probability of any event will be less than or equals to 1. That is, it is not less than 0 and not greater than 1. If the probability of any event is 0, then that event is called as an impossible event. That means sometimes we'll have some things which are impossible to do. That in that case of event definitely will not have any chance. So definitely the answer will be equals to 0. If the probability of any event is 0, then it is called as an impossible event. Sometimes we may have chance that 100% that is possible. That is called as a certain event or sure event. That is definitely it will happen. That is 100%. Then it is called as a certain event, and the value of that probability is equals to 1. So only in between 0 to 1, or else it is exactly equals to 0 or exactly equals to 1. If it is equals to 0, it is called as an impossible event. If it is equals to 1, it is called as a certain event. Same like this, we will be having complementary events. That is probability of any event plus the probability of not event is equals to 1. So here what is P of E and P of not E? Probability of event is something that will happen. Probability of any event, like how much it will be having and what is the chance of getting that event. And this is what is the chance to not to get that event. If we take one example, let's take 1, 2, 3, 4, 5. What is the probability of getting even numbers 1 and 2? So here it is 2 out of total outcomes, which is 1, 2, 3, 4. What is the not even? That is, what is the probability of getting not even numbers? That means this 2 and 4 are even numbers. So this will not comes under favorable outcomes of not even. So what will be the favorable outcomes of this not even? 1 and 3, which are not even numbers. So here also favorable outcomes are 2. So 2 by 4. As we know, 2 by 4 plus 2 by 4 will be equals to 4 by 4, which is 1. This is just an example. So this is how the conditions apply. Probability of event plus the probability of not event is equals to 1. And here we'll be having sample space. What is mean by sample space? Sample space. And this sample space is denoted by capital S. In this sample space, we will be having the set of all possible outcomes of an experiment. As I said, this only we will take. What is the sample space of this? All the elements which are into that condition, like 1, 2, 3, 4. All outcomes comes under the set of sample space, and it is denoted by capital S. So these are the basic concepts we'll be having in probability. Let's start with our exercise. So here we have our first question. A coin is tossed once. So here we have one coin which is tossed, and the question for this is describe the sample space X. So in a single toss of coin, we can find either heads or else tails. Only two possible outcomes we'll be having. So first question is to describe its sample space. So what will be the sample space? The total outcomes which are possible for this event, which is heads or else tails. This will be our sample space. And what is our second question? Find the probability of getting a tail. What is the probability of getting a tail? What is the event of this? Probability of getting event. This is nothing but number of events in that case. So what is the number of favorable outcomes, which is only one tail we'll be having. So the probability of getting one tail favorable outcomes will be equals to 1. So what our total outcomes will be denoted as n of s, that is number of elements in our sample space. So what are the total outcomes here? 2. And the probability of getting any event is equals to n of e by n of s, which is nothing but the favorable outcomes by total outcomes. Here we have our values 1 by 2. So this is the probability of getting a tail. So here we have our second question. Two coins are tossed simultaneously, where we are tossing two coins at a time. So here the first question is to describe the sample space. As we know, in tossing two coins, we'll get two heads or one tail and one head, or else one head or one tail, or else we may have tail and tail also. These are the four possible outcomes we'll be getting when we toss two coins simultaneously. So here we need to describe our sample space. So the sample space we can write it as head and head, tail and head, head and tail, and tail and tail. This is our sample space for this case. And here we need to find the probability of two heads. Two heads. So how many possibilities we have? Only one. So the probability of getting two heads is equals to only one, which is head and head. Only one event will be having to get two heads. What is our total number of outcomes? 1, 2, 3, 4. This we can write it right here, because always the total outcomes remains same. So what will be the probability of this event? N of e by n of s, which is equals to 1 by 4. Right? This is the probability of getting two heads when we toss two coins. And second one we have is probability of getting at least one head. At least one. At least one. One head. At least one head. What is the probability of getting at least one head? 1. Here we have 2, so this also comes under the favorable outcomes. Here we have one head, here also we have one head, whereas here we don't have any head. So this 3 comes under our favorable outcomes. What are those? Heads and heads, tails and heads, heads and tails. So what will be our number of events? 1, 1, 2 and 3. And as we know, the total number of outcomes always remain same. That is n of s is equals to 4. And what will be our second event probability? This we can write it as probability of event 1. And as this is our second, we can write it as probability of getting second event. That is 3 by 4. That means the favorable outcomes by total outcomes, which is equals to 3 by 4. And next we have probability of at most one head. At most one head. At most means maximum one head. We may or we may not have head. If we are having head, we need to take only one head. And here we have two heads, which is not a favorable outcome for this. Here we have one head, here also we have one, here, whereas here we don't have any head. This also comes under the favorable outcomes here, that is tails, heads, heads, tails, tails and tails. So what is the favorable outcomes here? 3, and our total outcomes are 4. So this is our third one, right? This we can take it as probability of E3. So favorable outcomes by total outcomes, which is 3 by 4. And next we have our next one, which is D, probability of getting exactly one head. Exactly one head, not zero or else not even two. Exactly one head. Here we have two heads, one head, here zero heads. So here we'll be having tails and heads or else heads and tails. So what is our favorable outcomes? What are our favorable outcomes? 1 and 2. And our total outcomes are 4. Thus, the probability of this is our fourth event, right? So, favorable outcomes by total outcomes, which is equals to 1 by 2. And our fourth one is probability of getting no heads. No heads means not even a single head. Here we have 2, 1, 1. Here we have 0 heads. So, no heads means only we can have tails and tails. The probability of this event 5 is equals to only 1, whereas our total outcomes are 4. So what is the probability of getting this event favorable outcomes by total outcomes, which is 1 by 4. So here we have a third question. 3 coins are tossed simultaneously. So same like the before one, here we have 3 coins which are tossed simultaneously, that means at a time. First we need to find the sample space. So here we'll be getting heads, heads, tails, heads, tails, heads, tails, heads, heads, or else 3 heads also we may have. Next, head, tail, 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 head, tail, 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 head, or else 3 tails. This is our sample space, or else these are our total outcomes which is possible when we toss 3 coins simultaneously. These are our total favorable outcomes. So what is the count of our sample space? How many outcomes we got? 1, 2, 3, 4, 5, 6 and 7, 8. This is our sample space, and here we got 8 events in that sample space. So first we need to find the probability of getting at most 2 heads. At most 2 heads. At most 2 heads means we can have 2 heads, 1 head, or 0 heads also we can have. So how many events we have like that with 2, 1 or 0? If we observe here, except this, every event is having at least 1 head, 2 heads or 0 heads also. So here we'll be having head, head, tail, head, tail, head, tail, head, head, or head, tail, 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 head, tail, 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 head, or else 3 tails also we can have. We should not include the event which is having more than 2. We can have 2, 1 or 0 also we can have. So how many events we got? 1, 2, 3, 4, 5, 6, 7. So the probability of this, that is n of events, how many events we got? 7. So what is our probability of getting total events? That means what is the condition? The number of favorable outcomes by total outcomes, that is n of e by n of s. What is our n of e, which is 7 by 8. So the probability of getting this first event, which is at most 2 heads, is equals to 7 by 8. And we have our second question, which is probability of getting at least. At least means minimum 2 heads. At least 2 heads. That means minimum 2 heads are mandatory, not even 1 or 0. So what are the favorable outcomes here? Heads, heads, tails we have. Heads, tails, heads we have. Tails, heads, heads we have. And 3 heads also, because at least 2 means we can have 3 also. What is our n of e, number of events? 4 we have. And as we know, n of s is equals to 8. So the probability of getting the second event is equals to 4 by 8, which is equals to 1 by 2. And next we have our question number, third question, which is exactly 2 heads. Exactly 2 means not 1 more, not 1 less. So from here we can have this, this and this, which are having exactly 2 heads. Exactly 2 heads, which is heads, heads, tails, heads, tails, heads, or else tails, heads, heads we can have. What is our n of e? N of e is 1, 2, 3. And as we know, n of s is equals to 8. So what will be the probability of getting this third event? N of e by n of s, which is equals to 3 by 8. This is a third question. So here we have our fourth question, which is a die. And we know what is meant by die, which will have 6 faces with 6 different numbers from 1 to 6 is thrown once. So a die is thrown once, and here we need to find few more questions, which is probability of an odd number. Odd number. So before that, we need to find the sample space. What will be the sample space for this die? We'll be having numbers from 1, 2, 3, 4, 5 and 6. These are the sample space elements of this event. So how many elements are there in the sample space? 1, 2, 3, 4 and 5, 6. This is our sample space. First we need to find the probability of getting an odd number. How many odd numbers are there? 1, 2, 3. So here we have 3 odd numbers, which are 1, 3 and 5. So the probability or n of events, how many events we have? 3, and n of s is equals to 6. So the probability of this first event is equals to 3 by 6, which is equals to 1 by 2. This is our first, and we need to find the probability of number which is greater than 4. So numbers or the events which are greater than 4. So what are the numbers are there which are greater than 4? Greater than 4 means 4 is also not included. So here we'll be having events 5 and 6. So what is the count of this? Only 2. And as we know, total outcomes are 6. The probability of the second event is equals to n of e by n of s, which is equals to 2 by 6. This can be simplified as 1 by 3. And next we have a third one, which is the probability which is less than 5. Less than 5 means 1, 2, 3 and 4. So here we'll be having 1, 2, 3, 4. So n of e, how many events are there? 4. And our n of s is equals to, it is always same, which is 6. So the probability of this third event to get less than 5 is equals to 4 by 6, which can be simplified as 2 by 3. Next we have our fourth question, the probability of getting a number 5. Number 5. So we'll be having only 1 5 here, which is 5. So what is our n of e? N of e is equals to 1. Our n of s is equals to 6. And the probability of getting this fourth event is equals to 1 by 6. This is our question number 4. So here we have our fifth question, which is 2 dice are thrown simultaneously. So here we have 2 dice which are thrown simultaneously, and here we need to find the probability of different cases. 2 dice. So what for one die we'll be having 6 possibilities. For second, again we'll be having 6. If we count it individually, we'll be having 6 and 6. But here 2 dice are thrown simultaneously. Simultaneously means total possible outcomes will be equals to total possible outcomes will be equals to 6 into 6, which is equals to 36 times. So total will be having 36 favorable outcomes for this. And here we need to find where the probability will be getting 10 as the sum of two numbers. So if you want, we can write our total favorable outcomes. It may take some time. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. So like this, if we write all the sample space event, we'll be getting like this, all the 66 favorable, all the 66 total outcomes. These are our total 66 possible outcomes for this event. First question is to, or the probability we need to find as 10 as the sum of 10 as the sum of two numbers. That means here we need to find an event where we'll get the sum of those two numbers as 10. So if we go with this, here we'll be having 4 and 6 which is equals to 10. This we have 5 and 5 which is equals to 10. 6 plus 4 which is equals to 10. Right. So here we have three events, that is 4, 6, 5, 5 and 6, 4. So n of events. How many events we have? 3. And as we know, our n of x is equals to 36. The probability of this first event is equals to 3 by 36 which is equals to 1 by 12. And the second one we have a double of even number. That means we need to get same numbers in two events where it should be an even number. A double of even number. That means here we need to get a set of two numbers where it should be an even number like this. Here we have 2 and 2, 3 and 3 also here we have, but we need to have only even numbers. So 4 and 4 we can take, 6 and 6 we can take. So here our favorable outcomes are 2 and 2, 4 and 4, 6 and 6. So our total outcomes, favorable outcomes will be equals to 3. Thus we can take it as n of a which is equals to 3 and our total outcomes is equals to 36. The probability of getting the second event is equals to 3 by 36 which is again equals to 1 by 12. And our third one we have which is total of at least 10. At least 10 means minimum 10, it can be 11, 12 or more also. Minimum we need to get at least 10. Total of at least 10. So here we'll be having up to here will not get any tens because it is only last is 3 and 6 which makes up to 9 only. But here we need at least 10. It starts with 4 and 6 and 5 and 5, 5 and 6 we can take, 6, 4, 6, 5 and 6, 6. First we'll write it here. 4, 6 we have 5, 5, 5, 6, 6, 4, 6, 5 and 6, 6. What are our total outcomes? That means number of favorable outcomes is equals to 6. And as we know, n of x is equals to 36. The probability of getting this third event is equals to 6 by 36 which is equals to 1 by 6. And we have a fourth one which is multiple of 3 as the same two numbers, sum of two numbers turn up to So here we have our question number which will be like if we add sum of these two events, it should be a multiple of 3. That means 3 we can have 6, 9 up to. Like if we add any two numbers of that event, we need to get it as a multiple of 3. So here we'll be having 1 and 2. 1 plus 2 is 3 which is a multiple of 3, right? And here we can have 1 and 5 which makes 6 which is also a multiple of 3. Like this we'll be having 1 2, 1 5, 2 1 again, 2 4, 3 3, 3 6, 4 2, 4 5, 5 1, 5 4, 6 3, 6 6. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number of events is equals to 12 and our total outcomes is equals to 36. The probability of getting this fourth event is 12 by 36 which is equals to 1 by 3. So here we have our sixth question which is a box of 160 electric bulbs. So what are the total number of electric bulbs? Total number of bulbs. How many are there which is 160. Out of this 160, thus 12 defective bulbs are there. So there we have total 12 defective bulbs. Defective bulbs is equals to 12. And one bulb is taken out at random. So first we'll find the number of non-defective bulbs. So how many will be having non-defective? Total minus defective, which is 160 minus 12, which is equals to 148. So there we have total 160 bulbs. Out of this 160, 12 bulbs are defective. And we need to find the count of non-defective bulbs, which is total minus defective. We'll be getting it as 148. And the question is, one bulb is taken out at random. So out of this total bulbs, one is taken out at random from the box. So here we need to find the probability that the bulb drawn is defective. Defective means from here, what is the probability that it may be any one from the 12. So what will be the favorable outcomes for first one? Defective. Favorable outcomes are 12, and as we know, total outcomes are 160, right? So out of this 160, we may have this 12 defective. It may be any one from this 12 defective bulbs. That means the favorable outcomes are 12 and this total outcomes remain same, which is 160. So the probability of getting this first event is equals to n of e by s, which is 12 by 160. This 3 4s are, or 4 3s are, 4 40s are. So here we'll be having 3 by 40. So the probability of getting a defective bulbs out of 160 is 3 by 40. And whereas we need to find the probability of getting non-defective. What are the favorable outcomes of non-defective bulbs, which is 148. Out of 160, we have 148 non-defective bulbs. So the probability of getting this non-defective bulbs is equals to 148 by 160, which can be simplified as 4 3s are 12, 4 7s are, and 4 40s are 37 by 40. So the probability of getting defective bulbs is 3 by 40, and the probability of getting non-defective bulbs is 37 by 40. This is our question number 6.